This is the final project presentation of Team Hail Hydra. Our topic is applying generative adversarial networks to do super resolution on 2D animation. Super resolution is that we do upsampling to increase the resolution of the given images. Traditionally, we use interpolation methods to upsample the image. However, this leads to some blur effects in the output images. The state-of-art uses generative adversarial networks, which is ESRGAN, to solve the problems and achieve the high quality. In this project, we utilize enhanced ESRGAN on the 2D anime images. This can be used in both improving the quality of the modern animation, but also remastering the old animation. In practice, we reuse the module of the model definition implemented by the author, and adapt them into our data pipeline, which is coded from scratch. Specifically, we choose Your Name as our target anime movie. Among 17-20 different scenes which contains multiple frames, we crop several sub-images and collect them as the dataset. As a result, we have 151,032 images in total as the training data.
As for dataset building, we cannot directly shuffle all frames from video because frames come from the same scene could be very similar. If similar images appear on both training and validation phase, it could compromise the validation effect. But fortunately, frames from different scenes are hardly similar. If we could make sure frames images for training or validation belongs to different scenes, we could avoid this conflict. So here is where the scene detection comes in. This is our overall data pipeline. First, we split up the video into small video segments using FFmpeg scene detection and build dataset over it. Each video segment includes only one scene. Next step, we extract frames from video segments with different resolutions. Finally, we could apply some data augmentations to improve our data diversity.
It is a generator of GAN. It has several convolutional blocks for extracting features at the top. After that, these features are passed into upsampling convolution layers for high resolution, and refining layers for subtle details. For a discriminator, it is a VGG-style straight feed-forward network for binary classification, to derive whether the input is from the ground truth or the generator. Here are those functions of the GAN. Both the discriminator and the generator are trained on update targets. Besides, the generator has three different components, which are perceptual loss, adversarial loss, reconstruction loss. Here are some training details for our project. It is worth mentioning that the whole super resolution network converges very fast. It can generate realistic results in roughly 2.5 hours on AWS P3.2x large. These are results from VAE baseline. As you can see, VAE seems unable to reconstruct clear and sharp images.
Here is our training progress. We can clearly see it from this diagram that as our models be trained more iterations, the super resolution results are more close to the ground truth image. This is our final result. You can see our model output is very close to the ground truth and has a higher resolution compared with the low quality input.
In this project, we apply ESRGAN to perform super resolution on the anime movie Your Name. The result is capable of recovering the most textures and details lost from low resolution videos. As for future work, we plan to use the discriminator in the perceptual loss calculation instead of the actual pre-trained VGG, and we hope to incorporate VAE features into the GAN generator.